Hi, my name is Muhammad Rafi Iqbal from Group 2. I want to introduce a topic that our group has decided on, which is Lorentz force. So, this is all my group members. Okay, now we move to the objective. The first one is to understand the Lorentz equation. The second one is to observe the motion of the rod. We will examine how the rod move under influence of Lorentz force when a current flows through it in the presence of magnetic field. And the last one is to understand the Fleming left-hand rule. We will demonstrate the left-hand rule for the direction of the force, current, and also for magnetic field. So now we move to materials that we use. The first one is battery holder, function for holding the battery securely. Second is 3.7 volt and 7.6 ampere rechargeable battery. This is to supply electrical power to circuit. The third one is U-shaped magnet to provide strong magnetic field. Next, stainless steel rod to conduct electric current and interacts with magnetic field. Next is molar stainless steel rod to indicate the direction force. And the last one is punch to provide support and stability to the setup.
About the theory part of our experiment, first of all, I will talk about the force on moving point charge. The relation between volume current distribution, or we say convention current density J, and charge velocity U is rho J equals to rho V times U. And the magnetic force on volume current distribution would be dF equals to J dV cross product with B, magnetic field density. And we extend this equation on moving charges to get dF equals to dQu cross product with B. Next, I will talk about the Lorentz force. When a charge is immersed in combined electric field and magnetic field, and the combined force will become dF equals to dQe plus the cross product of dQu and B. The Lorentz force act on a charge is a combination of a force in the direction of the electric field and a force at right angles to both the magnetic field and the velocity of the charge. In general, the Lorentz force equation is F equals to Q in the bracket of E plus the cross product of V and B. In order to determine the direction of Lorentz force, we can use Fleming left-hand rules to find the direction of the force acting on the current carrying conductor placed in a magnetic field.
Now I'm going to demonstrate the Fleming left-hand rule, okay, which consists of three parameters: the force, the magnetic field, and the current. Okay, this is how it's looked like. Current at the middle finger, the magnetic field at the second finger, and the force at the thumbs. Okay, by assuming this current flow through a cylindrical metal, we can see how it's going to work. Okay, let's take this. Okay, and the magnetic field is from north to south, so north at the below and the south at the upper plate. Okay, and it's going to work like this. So when the current flow through this this cylindrical metal, the force will be initiated. So it's going to go through here like this and like this. And this also can work on the opposite direction of the currents, which I cannot show because of the limitation space. We can see that in the experiment later. Thank you.